is electron spin? Simply explain. I'm going to explain here about the spin of electron, but in a very simple way, not in a book way, not in a lengthy calculation, equations solved. How you feel that what a spin is, how the electron spin behaves. Let's see. We know about from Schrodinger equation that electron is composed by a lot of matter waves forming some standing waves, means matter waves. The story of matter waves for electron. In Schrodinger equation, the energy was the classical kinetic energy or potential, classical energy. But Dirac realized that what would happen to electron when it moves with the speed of light or closer to the speed of light. Means we have to take relativistic energy. Dirac used relativistic energy in the equation like Schrodinger equation, means proceeding Schrodinger equations with relativistic energy, and he found something different, something more exciting. Look, Dirac took the value of this matter wave as this. The matter wave of Dirac particle is like this. It has 4 components of amplitude and 1 time component. In Schrodinger equation, 1 amplitude component and another time component. But in Dirac matter wave function, there are 4 components of amplitude and 1 time function. Here, we think Dirac wave for electron in 1 dimension, not in 3 dimension. For 3 dimension, I will go for a new video. For an electron moving in 1 direction, having all the 4 amplitudes along the same x-axis. Let's see, all these 4 amplitudes are along the same axis, x, they are function of x. After solving this equation, putting the value of this matter wave in Schrodinger-like equation, Dirac found that we have to put 2 of its amplitude 0. Any 2 of its amplitude component 0, then we can solve Dirac equation for the electron. Let's take this function. This is matter wave function in which this is some constant in the amplitude. 2 of its amplitude are 0. Taking second function, third function, eigenfunction of amplitude as 0. Fourth function is sine k pi x by l, which is the function of k pi by l along x-axis. This is sine function. The first component of amplitude, this is cos k pi x by l. It's the function of cos. It is also an imaginary term. It has some constants h cross k pi by 2mcl with I as imaginary number. This imaginary number suggests something here. What it suggests? Can you guess? Let's see. Imaginary I attached to this function means this function is least important in our behavior. While explaining, it has significance, but less significance. That's why it's imaginary. Generally in physics, where it comes imaginary term means it presents its effects, but everything we have to take less effect because why? It's less active in physical world. This is more active. This amplitude is vibrating at larger amplitude, and this amplitude, this component of amplitude is vibrating at a smaller length. That's why it has I. And this time component, this time function is as usual. We can take any value of k1, 2, 3, 4. It gives the standing wave analysis. Now see, this arrow shows that this is the spin down structure of an electron. When Dirac used this matter wave function to explain an electron at relativistic energy, it has some sort of solution like this, which is called a spin down. Why it is called a spin down? Similarly, we get a spin up state. See, plot this equation, this function. along this axis and plot this equation axis vertical orthogonal to this axis. They are not orthogonal, they are one dimensional, but as it is imaginary and orthogonal to this is orthogonal to this. That's why we have to plot this on an axis which is horizontal to this axis at an angle 90 degree. But they all are along the x-axis. While in physical significance, you have to think all the four components are in x-axis. It's a very strange. We have to think all these things in x-axis. But plotting takes some vertical and orthogonal axis. It's along 1D. Let's see. This is the function of sine, and it goes along this axis. This is a sine function, and the bigger amplitude component which is vibrating as large, means this could be predicted easily. So the electron we feel in laboratory and experiments, not more precise, a very nuclear level experiment, but experiments which are common to atom and molecules. For electron, we find this wave. This wave of cos function is plotted over an axis which is orthogonal to this axis, the green line. See, it's cos function, that's why it starts here and here. I just plotted it for half period, both the axes. See how it looks in physical domain, in our daily life things. See, this is my setup. Is it visible? Let's see. This is my setup.
No.
Okay. Wait.
It's on.
See, in this graph, this is the bigger component of amplitude, and this green one is smaller component of amplitude. Now see, in real world, I have used some apparatus, handmade apparatus at my home, and I'm trying to show you how we can think what a spin of an electron is, or any other particle. Let's see. The bigger component, see, the red one in the graph, is this component, okay? The red one in this graph, let's see. The red one in this graph is this bigger component. This is a sine k pi x bar function. Understood? Now a different one. The cosine function is like this. Means the other function is like this. This. Understood? That's the spin down state for an electron according to Dirac. Pause it. Earlier, there you saw that how a spin down state where the fourth component was bigger one, vibrating in amplitude, and the first one was a smaller one, amplitude, which is vibrating as a smaller vibration. And imaginary also means 0. Now, this is a spin-up state. When we keep fourth component of amplitude as 0, first as 0, second as a smaller vibration amplitude, and third one larger vibrational amplitude of Dirac matter wave, then the matter wave which is representing a particle is spin-up state. Means you have to notice here that in a spin down state, this was vibrating as larger amplitude, this was at a smaller amplitude. These two were 0. Now these two are 0. This is at larger amplitude vibration, and this is vibrating at a smaller amplitude. Means position has changed. And this is shown here in this graph. Earlier, the red bigger one amplitude was for this, and the smaller green amplitude was a smaller amplitude plotted over the green wave was this one. Now in a spin up state, sorry, let me to write this spin up state. This is a spin up state. This time the bigger vibrational amplitude, the component of amplitude of matter wave representing electron is vibrating at larger scale is this, the third one, and it has shown over this greener wave. Earlier the greener graph, the amplitude at green graph was a smaller vibrational amplitude, but now this is bigger one, means it has switched on. And the second one, which is vibrating at a smaller amplitude right now, this component is shown with red graph. Okay, the position had switched off, switched on. It had changed. Earlier fourth was bigger one, now third is bigger one. Earlier first was smaller one, now second is smaller one. Rest two components always zero. Why they are zero? Tell me. I will discuss it in another video. Now see here, the physical setup which described this graph easily. This time we are look at this graph, look at this setup. It is exactly replicating this graph which is on the board. Now it is in my hand. The green one is bigger right now, and this one is bigger this time. The sine wave, the third amplitude, third component of amplitude, and second one is red one, that is smaller. It's the cos function, and this is the cos function. See, this is the cos function, this is the sine function. So what have you noticed? In a spin up state, this one is bigger one, and this one is a smaller one, component of amplitude. In a spin down state, what have we noticed? This one is bigger one, and this one. What have you noticed as the spin? All these things give you an insight. Something has changed, something has twisted. You have seen from here to here. In a spin down state, this was bigger one, this was smaller one, these two were zero. In a spin up state, this is zero, this is bigger one, this is smaller one, and this is zero. It means bigger one has switched on from here to here, and a smaller one has switched on from here to here. Means they have interchanged. Means earlier it was vertical, now that one is horizontal. Earlier what was horizontal, now that one is vertical. And this gives you an insight. When we think electron as a Dirac wave, matter wave, which at relativistic energy level, then we notice that it has four amplitudes, means along the same direction, along 1D, where while trying to represent a 1D electron with relativistic energy by Dirac, it has four amplitudes. All these amplitudes are orthogonal to each other, means the product, the dot product will give you zero, and two are zero always. Any two are zero always to represent an electron in a state due to Dirac. And in a spin down state, one is maximum. In a spin up state, that will be zero. It switched from here to here. Now you have an insight what an electron spin. It can only explain over the matter wave function at relativistic level. If you think electron as a spinning ball, you can't understand this spin property because it's not like a spinning ball. It's like something, it likes a wave flowing. Something inside it had changed its amplitude. That's all. Now a question for you. We know electron has a spin number 1/2, means that it can retain its shape after 2 revolutions. Means orbiting by 720 degrees, it will retain its shape. Try how changing the positions of amplitude after 2 rotation how it will give you the same thing. That's for you, and I will discuss it in my new video. This is a spinor. This type of matrix which has the 4-column component are like a spinor, and that's why scientists say that spinors represent a spin property of electron and such fermions, such particles. That's for you. You can check how after 2 rotation this will be identical. After changing from year to year, how it will give you exactly the same electron. Phi 1/2 is the spin number of electron. Check it here. This is Mayer 1D equation. For 3D equation, like my channel, subscribe my channel, and I will do it in a new video. Thanks for watching.